Ooh, if all of you could turn to page 101, that would be lovely. Can I do anything with that? No, why not, Sophia? Because there's two different bases, right? If I'm going to apply exponent laws, I have to have the same base that I'm starting from, yes? Everyone understands that, correct? All right, so what if I am multiplying radicals? Square roots, roots, and roots. What do you think has to be the same? Where would you say is the base of this radical? Where would you say is the thing in this symbol that tells me how I am going to work with it? Is it the radicand or is it the index? It is the index. The index tells me what I am going to do with the radicand, yes? It tells me what size group I'm looking for. So if I'm going to multiply radicals together, they have to have the same index. Just like these guys have to have the same base. Okay? Now, you people are intelligent young people. 2x times 3x equals what? 6x squared. Why? Because 2 times 3 and x times x. Correct? Does everybody understand that? So, since you all know how to do this, you know that if you are going to multiply something, you have to put the coefficients, multiply coefficients, and variables, multiply variables. I forgot the A in variables. So variables multiply variables. Right? You already know this from the 9th grade, yeah? Okay. So what did I tell you about math? If it works once in math, it always works in math, correct? What does this expression, 2 root 7, mean? Two times the root of 7. What does this expression mean? 2 times x. So since we know what to do with 2 times x, and this is the exact same thing, I should know what to do here, shouldn't I? Without me even teaching you. So let's do that. What do I do with the 7 and the 5? Multiply them together because they are coefficients. What is 7 times 5? 35. So I have negative 35, correct? Then, of course, what do I do there? 3 times 8, just like I did x times x. So this is the root of 3 times 8, correct? Now, what is 3 times 8? So this is negative 35 root 24. Now there's a problem with that, isn't there? What is the problem with that? 24 simplifies. You would never leave 5 over 10 as a fraction, so you would never leave the root of 24, right? So, we should simplify this. Can I simplify it at this point? Pretty easily, can't I? Because what's 8? 4 times 2, correct? Does 2 have a square root? Does 4 have a square root? What is it? 2. So what comes out? 2. What's already out there? Negative 35. What did I leave under there? Under where? What did I leave under there? the 3 and the 2, which is 6. So my final answer is negative 70 root 6. Is everybody good? Everyone is good? Okay. So what's different in B? Anything? There's something different in B. What's different? There's no coefficient. What is the coefficient when we don't write a coefficient? 1. So, what do I do with 1 and 3? Multiply them. And what do I do with 8 and 2? What's the square root of 16? 4. So what comes out? What's already out there? 3. What did I leave under there? Nothing. So what's the answer? 12. Is everybody good? Great. You guys do C. I am betting that most of you are going to do this. Right? Okay, then what? What's the square root of 36? 6. So what comes out here? 6 times negative 48. And what do we leave under there? 6 times negative 48 is negative 288. 2. Everybody good? Now why did I leave this much white space, do you think? So I can show you something else. These are not incredibly large numbers, are they? They're not, right? But is it possible that they would be bigger? So, is it possible to simplify before we ever multiply? Yes. So you could do this way. Negative 8 root 6. That doesn't simplify, but this is 4 times 3, isn't it? What's the square root of 4? So this is 12 root 3, correct? Negative 8 times 12 is negative 96 root 18. Then I simplify that, 9, 2. Out comes the 3, negative 288 root 2. I can simplify before I ever multiply as well. When is that a good idea? If the radicands are large. And who decides how big a big number is? You do. If you're comfortable with the 12 times table, 6 times 12, leave it as 6 times 12. Right? If the radicands are large, and I'm going to put that in quotes because you decide if they're large, you can simplify first. But be careful. You still might have to simplify at the end. As needed. Afterward. Everybody cool? All right, what about D? What's the coefficient in the second one? 1. So what's 3 times 1? 3. And what's 3 times 3? What is the square root of 9? 3. So what comes out? 3. So what's 3 times 3? 9. Did we leave anything under there? No, so it's done. All right, now, E is tricky. What makes E tricky? There's brackets in front, yes? Now, all of you have done this in grade 9. Crap. See you in a bit. We are back on page 101. All right. Now, if none of this were here, what would you do with that? You'd multiply it out, and what would you get? $15 root 16, right? And then, if none of that was there, what would you get? Plus 10 root 24. And then, now what would you get? Minus 5 root 40. And that's what you do. Just like what you learned in grade 9. And which I'm going to be reminding you of when we get to polynomial multiplication. Now, what should you do with all of this, if you can? Simplify it out. Does 16 have a square root? What is it? So what comes out? What's already there? What do I do with those two numbers? What's 4 times 15? 60. Does 24 break down? Into what? I wouldn't use 12 and 2. I would use 4 and 6. Why? Because 4 is a square root. So what comes out? 2. What's already out there? So what do? Multiply to get 20 root what? 6. What about 40? Break it down into what? 4 times 10. Why 4 times 10 and not 8 times 5? 4 is a perfect square, so what comes out? What's already out? What do? Minus 10 root, what did I leave under there? 10. Everybody cool? You cool like that? Bum, 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 bum. What? Of course I'm going to do F. That's after E. Why would I do F before E? Oh, I see. You thought this was the time that I was going to say, now you do it. No. What's different about F? There's no coefficients, first of all. So if there's no coefficients, do I have to multiply any coefficients? No. Are they the same index? So can I multiply them? Sure I can. So now I got to multiply 16 times 54, don't I? That's a big-ass number. What is it? 864. How many people want to do the factor tree for 864? Not me, especially because I just explained how right above this point, right there, there's something that's a good hint. What does it say? Simplify first. So what is 16? Isn't that 8 times 2? What's the cube root of 8? Cube root of 8. 2, cube root 2. And 54 is 27 times 2, isn't it? What's the cube root of 27? 3, cube root 2. Right? Now, are there coefficients? What is it? 6, cube root. What's 2 times 2? 4. How much easier was that than doing this factor tree of 864? Way easier. How many of you on your test are going to multiply 16 by 54 and try to do that giant factor tree? A bunch of you. Because you are learning steps. Multiply the coefficients, multiply the radicand, simplify. You are not learning what you're doing. What's the most important word in that sentence I just made fun of you for? Multiply the coefficients, multiply the radicand, simplify. What's the most important word there? Simplify. Right? When should you be simplifying? Whenever you can. At the beginning of a question? Why not? In the middle of a question? Why not? At the end of a question? Why not? All three? Why not? So now that you have been given that tool, what are you going to do here? Are you really going to do 5 times 3 and root 28 times 63? Of course not. What are you really going to do? You're going to simplify. What is 28 really? 7 and 4. Why'd you choose 7 and 4, Charlotte? 4 has a square root, so what's coming out? What's already out? 5, so what is it? 10 root 7. What's 63? 9 times 7. Why did I choose 9 and 7? 9 is square root, so what's coming out? 3, what's already out? 3, so what do I get? 9 root 7, yeah? What's 10 times 9? 90. What's 7 times 7? 49. What's the square root of 49? 7, so what comes out? What's already out? So what's the answer? 630. Does anybody have a problem with multiplying radicals? No. I'm not a soccer player. Please. Oh, grabbing my ankle when something hit my head. Now one of you walk over and show a yellow card. Oh, there's the yellow card. Oh, I'm okay now. Let's play for 90 more minutes. Huh? Who am I making fun of? Who am I cheering for? Neymar. I want Neymar to come back and play in the final. I haven't had enough good acting this World Cup. I don't know. Who are you all cheering for? Huh? Pourquoi? France. Puh. Huh? I know. You promised me Belgium was going to win. I was voting for them too. No, of course I'm cheering for Croatia. Croatia doesn't have a lot going for them. I mean, they're the underdog. All right. Okay, now, stop for a moment. You guys are going to do page 102 in a minute and 103 in a minute. But I told you I wanted to show you something. You don't need to write this down because it's not really important for grade 10, but I do want you to see it, okay? You're smart young people. You know that 2 root 8 times 3 root 5 is 6 root 40, right? And then we would simplify the 40. You already know that, yeah? Okay. That's multiplying. What do you think is this? 8, no, I lie. 6 root 40 divided by 3 root 5. What's the answer? Obviously, it is 2 root 8, correct? Because we just did this multiplying, yes? Now, that should tell you... Oh, please finish. It's so rude to interrupt a conversation. I wouldn't dream of being that rude. Finish, please. Oh, you're done? Oh, excellent. Thank you. Again, same thing. It's so rude of me to interrupt a conversation. I wouldn't dream of being that much of a dick. So I'll just pause for a moment and let you finish your conversation. Oh, you're done too? Terrific. Thanks. Yes?
I was going to ask, are you going to simplify even more by doing it just square root of 4?
In a second. Okay? All of you already know this, yes? So that means because you know how multiplying works, for example, 2 times 5 equals 10, so 10 divided by 5 equals 2. It's the same thing here. Now, all of you should notice that when we multiplied, we did the numbers, the coefficients together and the radicands together, right? So when we divide, what do we do? Same thing. 6 divided by 3 got me 2. 40 divided by 5 got me 8. Everybody understand? That is level 1 of dividing radicals. Okay? All of you, it's not really part of grade 10, but I want you to see it while we're talking about multiplying. Okay? So if I gave you this, 6 root 18 over 4 root 2, what do you think the answer would be? I should make this easier for you first. Sorry. 2 root 2. What would the answer be? 3 root 9. And then we would simplify, yes? Okay. Now I'm going to change it slightly. Now I am going to do 6 root 18 over 4 root 3. Now what do you think the answer would be? Which part of it is bothering you now? The coefficients, right? Because this part is easy. What's that? Root 6. This is 6/4 times root 6, yes? Well, would you ever leave that fraction? What is it? It's 3 over 2 times root 6, correct? Is that root 6 a numerator or a denominator? It's a numerator because technically it's over 1, correct? So that would be 3 root 6 over 2. 6 divided by 4 is 3/2. Is everybody cool to there? Now again, this isn't really part of grade 10. I just want to show it to you now because of that thing that I hate in math class, right? Where they show you something and then they stop. So if I stopped at multiplying radicals, which is where I'm supposed to stop, next year in grade 11, they're going to go, all right, let's divide radicals. And you're going to be expected to remember the multiplying part. That seems silly to me. So I'm going to show you it now. Everybody cool? All right, now, what if I had this? 6 root 18 over 3 root 5. Again, you don't know what to do with this, so I'm just seeing if you can figure out something to start with. Where would you start? The coefficients. What is 6 divided by 3? 2. And that's a numerator, right? So it would be 2 root 18 over root 5. Everybody cool with that? Okay. This should bother you. Why? I can't divide that. And we've written it as a fraction, haven't we? And fractions are supposed to be rational numbers, aren't they? And to be a rational number, am I allowed to have a square root in the denominator? Am I? What is this number? It's a number that goes on forever, isn't it? And this is a number that goes on forever, isn't it? So I cannot divide a number that goes on forever by another number that goes on forever, can I? So we have to get rid of this. Right? Now in algebra, if I wanted to get rid of a square root, I have to do the opposite, right? What's the opposite of square root? Squaring. So if I multiply this guy by root 5, what is square root of 5 times the square root of 5? It's the square root of what? What's 5 times 5? 25. And what is the square root of 25? 5. Now, that's a regular number on the bottom. Are we happy? Now we're happy, right? But you know in fractions, if I do something to the bottom, I got to do it to the top, don't I? So what would I have to put here? Not 2. I only multiply by root 5. So there I got to multiply by root 5. So now I got 2 root 90, because 18 times 5 is 90. 2 root 90. And then what would I do with that 90? Simplify it. Because this is not allowed. Everybody understand? None of this will be on a test. I just want you to see it now so it's in your head somewhere. So when your next year's teacher starts talking about it, if you're in grade 10, you could say, oh yeah, that. This is called rationalizing the denominator. Now, wouldn't it make sense to finish up to here in grade 10 when we've started learning multiplying in grade 10? To me, that makes sense, but I don't make those decisions. So that's why I'm showing it to you now, even though I don't have to. Everybody cool? All right. It's all on YouTube if you want to watch it again, which you won't, but that's okay. Page 102, 103 is your work right now. It is 11:29. Break is at 12:05. I think, 25 to 30 minutes for this, and then you see the right answers. Yes? Go.
Are these addition signs or dividing?
They're adding. right, ladies and gentlemen. You have 8 minutes left, but I have recorded all the work for page 102. Here are the first 7 answers. Make sure you're doing it right. The highlighted stuff is obviously the final answer. If you need to ask about any of them, ask before you try going on to the last page. Yes. Which one, Erlen? Yes.
The first one should be 450.
Oh, 450, yeah. And there is 6, 7, 8, and 9. Now, I know some of you are going to say, Mr. Myers, you didn't teach us how to add radicals. But I did tell you they're exactly the same as variables, right? So 3x plus 4x is what? 7x. So negative 5 root 3s plus 3 root 3s is negative 2 root 3s. That is the type of thing that you are supposed to be using your own knowledge to figure out. And there is 10 and 11. Woo! Sorry. There's 10 and 11. Oakley dokley. All right. All right. On the screen behind me is all the work, of course. It has been being recorded because I forgot to stop it. There are the first 8. Any questions? Yep. So, in 6, I multiplied that in there. Since it's 1, it becomes 4 root 10. Then in there, which became minus 5 root 20. Then I simplified 20. 4 times 5. Out came a 2. So I had 4 root 10 minus 10 root, and I left a 5 under there. And I can't simplify anymore. Anything else from the first 8? 12? Okay, that would be from the second bunch, but yes. There's all the work for 9 through 12. 12 I simplified first. 9 times 7 to get 63. The square root of 9 is 3, so out came a 3. 3 times negative 2 is negative 6. 3 doesn't simplify. 28, 7 and 4. Out comes a 2. I already had a 4 out there. 2 times 4 is 8. Then I had positive 8 root 7s and negative 6 root 7s to give me a total of 2 root 7s. And I never touched the 2 root 3. Everybody okay with 9 to 12? Going once? Going twice? Going thrice? No, there's nothing past thrice. Quatrice? There's nothing past thrice. All right. Page 3 or 104. Now, do you people have the same printing error I have? Yes, for somehow B ended up down here instead of here. I don't really get it. So I'm just going to fix mine up to make it look a little better. Okay. So, you guys, it says fractional exponents, right? I don't know why I typed that, because the word is rational. I fixed it on mine. So, rational exponents. Now, that word rational, we have already talked about in the very first page of this unit. Rational means it's written as x over y, right? So now we know what to do with exponents when they're natural numbers. 1, 2, 3, 4, 5, 6, 7, and so on. We know what to do with exponents when they're integers. Negative 1, 2, 3, 4, 5, 6, 7, and so on. So now we've got to cover what to do with exponents when they're a rational number or a fraction. Now, a great many of you, again, have been through grade 10. You already know this, but the grade 9s won't. With your calculator, do this operation. So that is 9, then your exponent button. Son of a... Okay. So I asked you to start doing this on your calculator, which means you need to hit 9, the exponent button, and then 1 divided by 2. Or you can do 0.5, it doesn't matter. And when you do that, what do you get? Three. Now do the same thing here, except it's 27 and 1 divided by 3, not 1 divided by 2. What do you get? 3. And here, when you do that, it's 625 and 1 divided by 4, you're going to get 5. Now that should point you in a new direction. If 9 to the 1/2 equals 3, and the square root of 9 equals 3, then what do you know about 9 to the 1/2 and the square root of 9? They are equal. Does everybody follow my logic here? If this equals 3 and this equals 3, then these two must be equal, yes? Now, in this radical over here, there are two numbers that we normally do not write. What are they? What is missing right here? The 2, the index. What is missing right here above the 9? An exponent of 1, because that's the exponent that we never write. Now notice that in this radical, there should be a 1 and a 2. And notice in the exponent, there's a 1 and a 2. Right? Now check the next one. 27 to the 1/3 must equal the cubed root of 27. Again, notice, what's the missing exponent? 1. 1, 3, 1, 3. Does everybody see what is happening here? X to the mn power is the same as the n index, x as the radicand, and m as the exponent. That is the last of the exponent laws that you will be getting. It is number 8 or 9. Now, does that mean you can forget about the previous 7? No, they all still apply. So let's have a look at this question here. 0.04 is really 4 over 100, yes? To the 3 halves. Now, look at the rule. The denominator becomes the index. So what does that 2 become? The denominator in the exponent becomes the index in the radical. So what does that 2 become? The index of a radical. The base becomes the radicand. So what do I write here? 4/10ths. 4/100ths, I mean. And the numerator becomes the exponent. So all of this is to what power? 3. What is the square root of 4 over 100? Two over 10, all to the 3rd power. What is 2 to the 3rd power? 8. And 10 to the 3rd power? 1,000. There's my answer. Or 0.008. Is everybody good? Okay. Now the next one was 27 to the 4/3. Where does the denominator go? To the index. Where does the base go? To the radicand. And where does the numerator go? To the power. What is the cubed root of 27? 3 to the 4th power, which equals 81. Does everybody see how rational exponents work? Everybody? Okay. Now, as I said before, do you get to forget about all the other exponent laws? Of course not. That's like saying, well, I'm not allowed to punch someone in the face, so I stabbed him instead. That would be stupid, right? Okay. So here I have an exponent and another exponent, and there's a bracket between them. What is the rule that applies here first? I got to bring that over and do what? Multiply. What is 1/3 times 2? 2/3. 8 to the 2/3. Now, can we apply our new law? What does the 3 become? The index. What does the base become? The radicand. And all of that is to what power? 2. What is the cubed root of 8? 2 squared, which is 4. Does everybody understand what to do? Is everybody okay-ish? All right. Let's look at D. What is 0.49 really? 49 over 100 to the 1/2. Where does the denominator go? Index. So I need a square root of. Where does the base go? To the radicand. All of that is to what power? 1. Do we ever write 1 as a power? No, so we don't need it. What is the square root of 49? 7 over. What is the square root of 100? 10. And we're done. Or we could put 0.7. Is everybody good? All right, now tell me what's different about 3, and then tell me why it's not a problem. What's different about E? I should have said not 3. What's different about E from A, B, C, and D? The exponent is a decimal. We only know what to do when the exponents are a fraction. Can we convert that to a fraction? What is it? 1 1/2. That's still not a fraction we can work with. So this is 16 to the 1 1/2. We're still screwed. What do we got to do now? Improper, which is 4 over 2, 3 over 2. Now can we deal with it? Where does the denominator go? Index. Where does the base go? Radicand. Where does the numerator go? Power. What is the square root of 16? 4 to the third power. What is 4 to the third power? 64. I'll help you out there. Does everybody get it? Okay. What about that one? That is 81 to what fraction? 3/4. Right? Now, somebody said 75 over 100. That's cool. But would we ever leave that fraction? No, Mrs. Bag Crumble would kill us, so we would simplify it to 3/4. And now we're here. Where does the 4 go? Index. Where does the base go? Radicand. Where does the power go? 3. Simplify under here. I know 81 is what? 9 times 9, and I know 9 is what? 3 squared and 3 squared. Isn't that a group of 4? So what is the 4th root of 81? 3 to what power? 3. What's 3 to the third power? 27. Can everybody do these ones that work out perfectly? Yeah? Okay. I'm going to walk away from them for a moment because does every fraction work out perfectly? When you're working with fractions, does it always work out? No. So let's check this situation. Oh, Myers, you're not fooling me. I know that's the 5th root of 8 squared. I got you. Except 8 doesn't have a 5th root, does it? What's the biggest root 8 has? A 3rd root. Because the 3rd root of 8 is 2, right? 2 times 2 times 2. So this doesn't exist, does it? So if it doesn't exist as a number that we can work with, I have to use my calculator. Okay? That's why I've said use a calculator to simplify. If the fraction forces an irrational root, like this, then we must use a calculator. There's no way to make it any simpler. Okay? Everybody understand? So how would I do this on my calculator? It would be 8 exponent button bracket 2 divided by 5. And it'll just give you a big stupid number and you don't have to worry about it. All right? Everybody cool? In math class, we would have to leave it as this or this. That is math class. In the real world, this decimal exists, right? And you may have to assign a value to it. Which means all we do is we assign a value to it and then round it off to an appropriate number. Right? Everybody understand? So this guy is going to be the 7th root of 0.6 to the 15th power. Obviously, that's not a real number. So for that, we would have to use our calculator. Is everybody with me? Go ahead and try just to make sure. So 0.6 exponent button bracket 15 divided by 7, close brackets, equals. Barf. Everyone can do it though, right? Right? Okay. Now, if you turn the page over, you're going to see a time when you are going to be forced to do this. Here is what I mean. Biologists use this formula. All right, are we in math class now? Biologists use. So are we in math class anymore? No. So we're identifying the brain mass of an animal. Do I need a value for that? Yeah, of course you do, right? Like if I were going to tell you my mass, which is I had to put it in math, 95 kilos, I would not tell you that my mass was 2 to the 8.5 power, would I? No, I would give you a value, yes? So, because we're outside of math class, we're going to need a value here. We wouldn't leave it in radical form. Does everybody understand? But we know how to do it. A dog is 27 pounds. B is the brain mass. M is the dog's mass. So B, brain mass, equals 0.01. What's the mass of the dog? 27 to the 2/3, right? Now this one is going to be just fine, isn't it? Because that is 0.01 times the cubed root of 27 squared, correct? Right? What's the cubed root of 27? What's 3 squared? 9. So it's 9 times 0.01, which equals 0.09. That one worked perfectly, yes? Would we have gotten that pretty an answer if the dog weighed 32 kilograms? No. If the dog weighed 16 kilograms? Would we? No, because they don't have cube roots. So we would be forced to use our calculator and get some weird number. Does everybody understand? So let's look at this one. We're not going to do it because it's not really, necessary. 27 worked because it has a cube root. Does 200 work? No. So this one, we'd have to use our calculator and get a really weird number, right? This one is a calculator one. Because the cubed root of 200 is irrational. Is everybody with me? Now, if this was my regular math class, we'd take like 10 minutes and we'd practice punching this into a calculator so it would work for us. Because I like to show you how we take math into other classes. We're not going to do that today, right? I'm just explaining to you when you might go to your calculator. If it's not going to work out perfectly, you have to. What about 60? Will 60 work? Yes or no? Why not, Jeshan? Yeah, 60 doesn't have a cube root. Would 64 work? Yeah, because 64 has a cube root of 4. Is everybody with me? Everyone's cool? Because in biology class or in physics, we need a value, right? Just like when we go to Home Depot, we don't say, I need 66 pi worth of paint. You tell them how much square feet it is, yeah? Everybody's good? All right. In that case, there is some practice, page 106, if you need it. I'm not too concerned about it, but if I were you and I was only going to do a couple of these, I'd have a very good look at 4. I'd have a good look at, actually I'd look at 4, 5, and 6 if I was trying to focus. and I'd have a real good look at 10, 11, and 12. If you're comfortable with them, you're sitting at a good C plus B level. If you want to get that A, then make sure you're comfortable with 13 through 19. Everybody good? Now listen to me closely. I'm going to explain this. We are in our last block of the day. We got to practice and review here. This is where we are right now. All right? If you look in your books, the next page, you have the answers first. Your next page is page 108, yeah? Page 108 all the way to page 117 is nothing new. It's practice and it's review. So page 108, 109, 110, 111, 112 are all practice. You don't have answers for all of it. You have answers for all the textbook pages. You have no answers for 108 and 109, and I think maybe 110. For the rest of today, you're working. All right? Tomorrow, in the first block, I'm going to give you the entire first block to finish up to the end of your review on exponents and roots. Does everybody understand? That is up to the end of page 117, I believe. I will give you until the end of your first block tomorrow, which is at 9:15. But at 9:25, you're starting your cumulative. Now, Erlen asked earlier, will I give you some time to ask me about surface area, measurement, and trig? Your whole first block tomorrow is yours. Right? Second block, you're writing your cumulative. Third block, we're going to be marking that review. 4 marks. All right? So really, you have until 10:55 tomorrow to have up till page 117 done. Which means if you finish your cumulative early, there's some more work time there, yes? Everybody understand what I'm saying? We're going to be marking page 113 to 17, whatever that review is, at 10:55 tomorrow. We will mark it and we will start our 4th unit. Now, as I said, my goal is to have your cumulative marked and your check my progress marks up to date by the end of tomorrow's class when I hand you your interim to take home. Okay? If I can't get everybody's cumulative marked, then your cumulative won't be on there. If you have parents that are going to give you a hard time because you're not doing very well, and you say, oh, but Mom, I did better on my cumulative. I know I did. I am more than happy to email, because I do not want to waste the resources, I will email your parents an updated interim report after Friday when I have marked everyone's cumulatives, if I don't get them done tomorrow. However, to do that, I need an email address from your parents. I have some of them from their registrations. I do not have all of them. Okay? So, if you need that, if your parents are going to give you a hard time because you're getting like 53%, but you know you did better on your cumulative, then you're going to want to get your parents to send me an email, so I will email them an updated one. Does everyone understand? Okay. I'm going to shut up because I'm getting a bad headache. I don't know why, so I would like to stop talking. It's not from slapping myself in the head. I slap myself in the head all the time. It was starting before that. Okay? So I would like to stop loudly speaking. I will still come around and help you, but I would like to be done lecturing. Is everybody cool? Everybody feels they have enough, their feet are far enough under them to work for a while. So,
Tomorrow for the cumulative, do we have, this is the second one from 9:25 to 10:30?
yeah,
What time frame?
for the cumulative, yeah. Yeah. Everybody cool? Okay, go.